Welcome everyone to our next episode of DC Thursday. I'm Pete Soderling. I'm the founder of Data Council and the Data Community Fund. And I'm happy to be here shepherding you through the crazy, sprawling, immense, vast data ecosystem. And thank you for those of you who have been following us for all these months through the pandemic. We're getting excited to come back to live events in person sometime soon, so stay tuned for announcements there. But in the meantime, we're happy to be continuing to stay online and digital, and we're glad that you're able to join us today. So I'm extremely excited to announce our guest today and introduce him. It's Nick Schrock, who's the founder and CEO of Elementl. And Elementl is the company behind the Dexter open source project. Formerly, Nick was a software engineer at Facebook and Microsoft, and he's perhaps best known for being the original co-creator of GraphQL. So Nick, thanks for joining us today.
Thanks for having me, Pete.
So Nick, you've spent a lot of time in developer tooling, and the folks in our community know you through your work on Dexter as of the last few years. But before that, I just want to, sort of catch folks up on some of your background and how you got into the data world in the first place. I know that at Facebook, obviously, you were involved in the GraphQL language and designing that. I was curious, how did you move from sort of the GraphQL domain into the modern data domain? How did that happen?
Yeah, it's a great question, Pete, because I actually didn't, GraphQL and related technologies that I worked on at Facebook were targeted towards application developers, people building web apps and mobile apps specifically, and consumer apps. And I left Facebook 2017 and was figuring out what to do next. And I was talking to legacy, not legacy, software companies, and also companies that do software, which means every company. And I originally was like exploring avenues like healthcare and kind of other places that I thought would be interesting for interesting to kind of see what would happen to adopt modern technologies. And I kept on asking them what their biggest technical liabilities were. And this notion of data infrastructure and ML infrastructure came up over and over again. And then I was like, that's interesting. I wonder what all the companies around Soma and in the Valley say. And I started talking to them, and lo and behold, the same thing kept on coming up over and over again, that data infrastructure was just this enormous technical liability and a huge source of productivity issues and a really, a huge barrier to making progress in their various businesses. And, when I'm just so compelled to work on developer productivity and serving engineers that when I kind of hear about or see that sort of developer experience dumpster fire, I'm just like drawn to it like a moth to a flame. And, upon investigation, I discovered what, I like to call it the biggest gap between the complexity and criticality of a problem domain and the tools and processes to support that domain that I've ever seen in my career. That was certainly true in kind of 2017, 2018. And I think a lot of other people recognize that too, why there's so much activity in the space. But and it's actually a deceptively complicated and sophisticated domain as well. So I just kind of got into it and started looking into it, and I was hooked. And I'm really compelled to work on this problem space.
Yeah, the complexity sucked you in. And before that, I think many people might not know that you were also involved in developer tooling and infrastructure type stuff, even before Facebook and GraphQL. How did those experiences shape your career?
Yeah, I've always been super interested in it. I worked for a year at Microsoft in the developer division. And, I was actually, I didn't really, to be fully honest, like I didn't really accomplish that much in that year. And I actually went to the London School of Economics after that and like thought about not doing software, but I still like loved developer tools back then, and the developer division had incredibly talented engineers, and I really looked up to especially like the C# team, and really liked the way they approached things, and that was definitely an early influence. And then, what I found is that I kept on, I got back into software. I worked for a healthcare startup, and then I kind of, for a little bit, tried to start a fintech startup as well. And while I was working on those problems, I kept on attempting to do product and failing because I would start building the product, and something about the way that the system was structured would like so kind of offend my sense of trades craftsmanship that I would be sucked into building infrastructure. Because I would see my colleagues like doing all this repetitive work and wasting their time and whatnot, and that just drives me crazy. So I always kind of ended up supporting, no matter what I tried, I would always end up supporting the other developers around me and trying to like make them more leveraged as opposed to working on the product directly. And that pattern followed at Facebook too. I kind of initially was working on product at Facebook, and then hopped down one layer of the stack and formed a team called product infrastructure. So it's a kind of repeated pattern throughout my career.
Got it. And back to the Facebook, since you mentioned it again, there was sort of a parallel work or some support between the GraphQL team and the React team. I think I've heard you mention this before. So somehow you were involved, at least tangentially, in both. Can you explain that?
Yeah, I didn't work on React directly, but it was a team we were highly affined with, meaning like we could, we sat close enough where we could yell hear each other talk and whatnot. So we were highly affined teams, and then philosophically the systems were very similar. And then they would have, I was really passionate advocate, especially for React Native, and they would, I would help evangelize it on their behalf a little bit.
Got it.
But the team, those two teams came from the same DNA, I would say, in terms of the approach. And I think any user who uses both GraphQL and React at the same time can kind of see the similar taste, aesthetic, and some of the underlying design principles.
Got it. So then, stepping out of Facebook, you decided to get into the data world. What was your perception of the state of the union of data tooling, data infrastructure, when you decided to attack this problem?
So it reminded me of web development in the late 2000s, both in terms of technical properties as well as cultural properties. So what I mean by that is that, if you're a developer in 2010 and you're working in like a non-JavaScript normal code base, the moment that you hop in to a JavaScript code base in that era, you almost like regress as a developer. Like there's guaranteed to be no tests, your development flow is totally broken. You're just fighting the browsers constantly. The frameworks aren't developed. Like all your tools disappear. And therefore it's almost like you're kind of traveling back in time. And then people didn't want to work in that domain. They would kind of like just do as little possible, do as little as possible in those code bases and get out. And they would say they were spending all their time fighting the browser. And I think the data domain is in a similar spot still. And there's both cultural and technical artifacts around all that. So a cultural like property is, there's a lot of like self-deprecation around like, oh, I'm just a data janitor, I'm a cleaner. And then you go to a data science conference and they say like, I spend 90% of my time data cleaning, which would seem like a big problem if you think that. And the implication is that 90% is not part of their job. And that just like echoes from that previous kind of analogy. And then, if you take, it's a similar thing. You take a developer who works in one domain and they write tests and they have a nice developer workflow using all these tools. Then you plop them in data. The constraints are different, the tools are different, and kind of everything grinds to a halt a bit. Like people are much more fearful of changing things. There's not as fast developer life cycle. it's just extremely challenging. And, that's kind of the perception that I have. I think things are getting incrementally better on that front, in terms of developer experience, but there's still like so far to go, And in fact, there's so many tools being added to the ecosystem now that's almost like increasing the problem in a way, because it's like incredibly confusing in terms of what tool sets they should be using and whatnot. So I think it's still, there's a lot of people doing a lot of good work in this front, but it's still in quite a difficult spot for a data practitioner making their way in the world.
So you're not only an engineer, you're a builder of tooling for engineers. You have a bunch of experience doing that, and at least one successful project under your belt. You're looking at this morass of the data ecosystem. How do you start to figure out where's the right place for Nick to work? What's sort of the mental model that you used to figure out where you're going to jump in and to have the most value?
Yeah, I typically start from the developer experience standpoint, meaning understanding what people are doing, what their goals are, and then how they achieve that goal, kind of in a tactical sense, like literally watch them on a keyboard. That's generally the starting spot for this, because you start somewhere. And I consider that is like the leverage point of like understanding precisely at a tactical level what developer experience you're fixing. And then from there, if you come up with a better developer experience that imposes the correct level of constraints and with the right level of flexibility on that developer, but then you can use that new abstraction layer to like increase organization, like make it easier for the organization to operate within the system, or even improve the technical qualities of what's going on. So I usually start at the developer experience, use that as a wedge to kind of expand the architectural space and the way even the organizations operate. And think of it kind of in multidimensional terms like that. So that's typically where I start. In the case of in data, what I noted was that there is a single core activity that nearly every data practitioner does. And that is they build graphs of computations that consume and produce data assets. Whether you're an ETL developer, a data engineer, a data scientist, an ML engineer, at the end of the day, that is what you're doing. You are writing these graphs that ingest some piece of data, do some compute, and then produce something else, whether it's a file, a table, a machine learning model. But it's fundamentally all the same activity. And I thought the developer experience around that most core of activities in data was fundamentally broken, is what I identified.
And did you sort of see this as a quote orchestration problem at the time? Or, I think today, if I'm not mistaken, and you'll tell us more about Dexter, I think you would call Dexter a data orchestrator. Is that correct?
That's correct. So initially, I didn't view it as an orchestration problem because orchestration is one aspect of it, meaning like that's what happens when you deploy these computations to production. Like you are orchestrating the data around. To me, the initial framework was not orchestration, but just instead like the API and the programming model in a more kind of purist way. That you should be able to write these graphs as computations as simple Python functions and have a really nice developer experience around it. Now, it turns out in order to accomplish our objectives, we need to vertically integrate more and have control more of the infrastructure in the deployed compute environment. And also we need to go where the users were in terms of terminology and what, like, when they're approaching a system like Dexter, they think of it in terms of either workflow management or orchestration. And you need to use familiar terms that folks can grapple with. But I think Dexter really views orchestration as a broader, it should have a broader purview in the data ecosystem because it should be the subject of a full development lifecycle and a well thought out programming model, and not just a way to kind of order scripts in production. So that's kind of the evolution of how we started from there and got to the description as a data orchestrator.
Got it. Well, I'm almost reticent to ask you what could be a bit of a remedial question, because you're so well known in the data council community, and I'm assuming that many folks watching today are already familiar with Dexter. But before we go further, why don't you take the floor and just tell us what Dexter is, so that we have sort of a common language for everyone forward.
Totally. So Dexter is an open source Python framework. So you can pip install it, and the goal you're trying to accomplish when you're writing Dexter is you're writing graphs or DAGs of computation. DAG meaning directed acyclic graph. If you're for less technical audiences who aren't familiar with that term, I often analogize it to a factory where whenever you're putting data products into production, you're generally actually assembling an assembly line, either run by one or it's been built actually by multiple people. So the data engineer builds a machine which takes data, ingests it, and then spits it out. That goes to the data scientist that then has a different machine that ingests that and spits it out. And effectively, the orchestrator is the thing that is the blueprint for the factory, so to speak. So the practitioners build that machine, the orchestrator orders those computations and allows you to stop the assembly line and restart it and whatnot. So that's kind of in the high level abstract, the problem that Dexter is trying to solve is kind of, a bunch of people are coming together to build this data factory. And you need kind of a structure and a way to interconnect the components and operate the factory in a uniform way, while supporting the fact that lots of different people are coming to the table with their own tooling to do their job. So that is the kind of the analogy version of what we're trying to solve. For the engineering audience, you are writing DAGs, and you are effectively doing data computations and doing that in a graph structure. And we just allow you to write plain old Python. And you can write functions which say take data frames and produce data frames. You have a local testable environment for that. And then you can deploy those computations in production, and order them, and then also track the produced assets. So we really view ourselves as a full lifecycle orchestrator, where we really think about not just the deployed context, but also the dev and test experience. Then you deploy and execute those computations. And because the computations are data aware, we track and manage the actual asset production at the end of the day. So, we really like to think of ourselves as an end-to-end solution for building data-aware DAGs with a really smooth dev and test lifecycle as well.
Got it. And what are the core abstractions that you're working with in Dexter?
Yeah, so that is at the basic level, the kind of core abstraction is this pipeline, consists of nodes of compute that we call solids. But you can think of those as tasks. We are going to, well, I won't get into that, but we may be changing some naming around this stuff fairly soon. And you assemble these pipelines out of these solids, and these solids are data aware. So traditionally, tasks in these systems are not data aware. You just have a task and it's connected with an edge to a previous task, and there's no notion of data passing. In Dexter, you write a function, it's data aware. That way the system can handle, if each of those tasks end up operating, for instance, in different processes across a cluster, the system will take care of marshaling that data from one node to another. So that's really important. That allows us to do kind of nice features like being able to re-execute re-execute computations from where they left off. And it's just generally really nice for a developer to be able to think in data dependencies, so they don't have to have think of like two things at the same time, meaning like the ordering of computations and the data dependencies. Another really important part of Dexter is that we have an explicit way to model the operating environment where you are executing. And this is really important if you want to be able to write data pipelines that can execute in multiple different places. So for example, on your laptop, in a CI/CD pipeline, and in production. So you can, for example, write a function which just takes a pandas data frame and produces a data frame. On your laptop, you might be passing that data between the different processes if you're doing multiprocessing by persisting it to a file. But then once you deploy it, a file in the file system, but once you deploy it to production, you might want to be persisting it to S3, for example, in AWS. And what this allows you to do is you can maximize the amount of code that you can test in an environment neutral way, meaning that you can have this fast developer loop on your laptop or in a just a fast developer loop in general if you need to develop in the cloud. And this is really the first thing that our users grasp onto, where they just feel this like new level of empowerment of like, oh, what, like this is the first this is the first pipelining framework I've ever used that thinks about the developer experience first. And that like is like the first thing that people notice about it. So, and a critical component of that is the structuring of resources. We believe that DAG should be typed. So we have the ability to type the edges of DAGs effectively, well, the inputs and outputs. And so, and because data is, it's very hard to make universal guarantees about data because everything's so domain specific and whatnot. We have this very flexible type system where it allows you to kind of, make arbitrary effective data quality tests associated with edges of DAGs to ensure that, yes, the data that I'm getting is actually what I expect.
Got it.
So we have a basic type checking system as well. Typically these data pipelines have a lot of config they need to manage. And often those can be, big unstructured blobs that are undocumented, and it's really easy to make errors. So we come with also an opt-in schematized config system so that if you, for instance, misspell a key in a dictionary or in a YAML file for some configuration that the computation requires, we can provide tooling like our auto-completing config editor, which is like an IDE almost, and then and also provide super high quality error messages rather than like some inscrutable error that you might catch in production.
Sure.
So that's another really important thing. And then the other kind of core abstraction which matters a lot is that our computations produce an immutable stream of structured data that describe what has been happening in the computation. So, all other systems I know about don't have something like that. They capture just raw logs, which is a minimum. We also do raw logs because it's a minimum requirement for observability and whatnot. But I like to call logging developers thinking aloud. I mean, it's unstructured. People just put whatever they want into text. Often you end up like very difficult to sift through. We actually produce this structured log, which you can filter, have specialized display, which makes it, for example, instead of like combing a huge log file for some stack trace, we can just, as you type, find like the error that occurred in a particular run of a pipeline and immediately surface like a really well-structured error message. So, it's that immutable log is really powerful, both in terms of debugging and observability, but it also serves as a system of record for all your data computations. And it's how we build up various metadata catalogs that we have in the system as well. So the structured event log is kind of a critical thing as well.
So
go ahead.
So fascinating. There's a couple questions I want to ask you at this point. one is kind of going further down this road that you just started on, and if you don't want to go down there, let me know. But to what extent is Dexter going to build a data catalog, or going to build a data lineage system, or right? There's all of these other sort of categories of tooling that's popping up in the modern data ecosystem, and it seems to me like based on the way you're chaining these functions together and the inputs and the outputs and the strong types and all these things, like, does this become some sort of data lineage system in the future, or what are your thoughts on that?
It is a data lineage system now. So you can produce, we have a kind of a feature within the system we call the asset catalog, which is an integrated, what we call an operational asset catalog. We envision this working in concert with systems like Amundsen and Data Hub, which have Data Council affiliated systems.
Mm-hmm.
But we think it makes a ton of sense to vertically integrate asset awareness into the orchestrator, and it's incredibly powerful. So one is that the orchestrator, especially a data aware one, already has all the information.
Mm-hmm.
You have the dependency graph of the compute. You have data aware edges in the graph. So actually, with very little additional information, we can compute reliable asset lineage. And so it's like, and you don't have to integrate an entire other system just to get that capability going. It also enables really interesting operational use cases. So, for example, imagine that you find some table in Snowflake or a file in a data lake, and it looks weird, you don't know what it is, et cetera, et cetera. And if you want to figure out how to debug that thing or find the person responsible for it, you can just go to our tool, and we have a well-formed index. And if that asset had been produced by a Dexter pipeline, you can just type in like stories, the table, and immediately jumped immediately to it. And then you have a page that links the asset to the computation. So you can have the history of like when it was touched last, some longitudinal information. And we think this is a much more natural way to operate an orchestrator, because none of your stakeholders care about your pipelines. No one cares. It should be an implementation detail from their perspective. All they care about is the data assets that they rely on. So what we found is by having this kind of different index into the orchestrator, it actually opens up many more stakeholders to use it much more naturally. So because the orchestrator already has the information, and we think there's a lot of interesting capabilities that you can unlock by vertically integrating an asset catalog with the orchestrator, we build that in, and the users that adopt that derive enormous value from it. But we have no plans to kind of expand to all the use cases that a fully dedicated data catalog does, which might like scrape existing data sets for schema and be tracking like ad hoc use of data sets. And there's lots of and really complicated ownership ontologies. We don't anticipate going into that sort of thing anytime soon. So we view the operational asset catalog very much as a complement to kind of more full-fledged special purpose data catalogs.
Got it. It almost feels to me like, sort of based on the way you're talking about the system, and especially the way the system is architected, again, with these chains of functions that are all sort of parameter aware, it almost feels like you're taking us down this road of the DAG itself as an application. Like, what are your thoughts on that?
Yeah, I mean, that's how we think of it. And that's how we kind of, an initial phrase we used was data application, where, we kind of define these graphs as data application. I think this is a big mental shift in the system, is that typically in traditional workflow engines and orchestrators, kind of the orchestrators invoke scripts. and the scripts are the thing that developers operate on. And then
And
only
this
very
is like
late.
this is an Airflow. Sorry, this is like an Airflow paradigm, right? Like
Exactly.
Yeah, which is basically a sort of a step up from actually like cronning bash scripts, like presumably teams used to do in the good old days, right?
Totally. Yeah. How I like to describe the old world based on that factory analogy is, imagine a factory, but all the people in the factory were blindfolded. And then just at a certain time of day, they would have to blindly look to get the thing that came out of the previous machine and put it through the machine. And then you just hope that the right thing is there, which is literally how it used to work. And, so Airflow and other systems like that were a huge advance over that, and really important. But, when you look at a lot of companies, they might have an Airflow installation with thousands of DAGs, and they might each have hundreds or thousands of tasks. And the notion of kind of not treating those artifacts as full applications themselves, I think, is a huge reason why these systems often like collapse under the weight of their own complexity and become very almost like terrifying to change, because there's no good local development life cycle and no way to do kind of integration tests in a safe way. And therefore, people are just terrified of changing things. So if you instead view the graph as an application that you've been able to decompose, test in isolated components, be able to execute arbitrary subsets of those graphs, have it subject to a full developer lifecycle, kind of be able to refactor it in a way that's much more similar to refactoring traditional code. All these things combine to make it so that you can just manage the complexity of these things much more readily, and kind of apply more traditional software engineering tools and processes to the DAGs themselves, which we think is critically important.
Yeah, that's really cool. I love the thinking behind that. So sort of away from some of the design, architecture, and the thinking behind the system, maybe taking a little bit more practically. At what time does a team graduate up to Dexter? Like, what's happening in their data platform? What's breaking? What's the pain point? Sort of what metrics are increasing that they don't want to increase, or whatever. Like, what are the signs that a team is ready for Dexter?
Yeah, so there's kind of three. I'll go through three kind of typical times that we've been hearing about a lot. One is what I'll call the modern data stack persona. So it's someone who set up what is currently kind of being called the modern data stack. And that would consist of an ingest tool like Fivetran or Stitch. They ingest that onto a cloud data warehouse like BigQuery or Snowflake. Then you might use dbt to do all your SQL transformations within the data warehouse, then have a modern BI tool like Mode, pull data out of that data warehouse for dashboards and analytics use cases, and maybe a operational analytics or reverse ETL tool a la Census or High Touch, which can jam the data warehouse data back into other application systems of record. And you can get quite a ways with that, but there's definitely a hard stop you reach if you try to do anything that's outside of a fairly narrowly prescribed set of use cases there. Effectively, the moment that you one is that the tools themselves actually need to be operationally hardened a little bit. And in that world, right, where you have like both say Census and Fivetran and dbt running, you actually are back in a world where you have three interleaved cron jobs again. You've kind of like gone back in time. So you generally need an orchestrator there. And then if you do something like try to like incorporate a team that wants to build, say, Python-based data pipelines into that world, now they're totally like you have to bring in a new tool to support that. So, I was talking to one of our users and he said, yeah, you bring in Dexter when you want to make the modern data stack of modern data platform, was kind of the way he phrased it. I was like, wow, do you want to join our company as a product marketer? So that was great. So that's one case. Another typical time is this greenfield, where especially teams that are doing pure Python-based data processing, saying like pandas, typically in ML, like pandas, scikit-learn, PySpark, and they just like are very attracted to the programming model and adopt it straight away. I think, and then another case is where someone has reached the limits of the complexity that can be handled by a traditional workflow manager, and the whole notion that the DAG itself should be subject to a fast development lifecycle, that just clicks with them. So, for example, we work with Mapbox, and they were in particularly attracted to the local development programming model aspects of it, because they were actually spending something on the order of 50% of their compute budget actually on R&D, not their prod stuff, because they couldn't really parameterize the environment and program flexibly so they could operate in two different contexts. And they used Dexter to enable local development workflow, which reduced their spend so much that their manager called them up and made sure that the system was still working. But they're like, no, we just were using this, new programming model, which allowed us to kind of run on smaller data sets and run on different compute substrate, which dramatically reduced their R&D cost. And then, so that's another example. And they also kind of felt that Dexter was a great way to more manage the complexity of their DAGs, because the functional programming model made sense to them and other issues. Those are kind of some typical use cases.
Yeah, that makes sense. What's the lift like for a team to start using Dexter? I mean, I look at the documentation and it's, to me, it's deceptively simple. For sort of the power that is belied and sort of under the covers of the system, it seems like a very straightforward programming model. What are the sort of the real world gotchas, if there are any, in teams like actually getting on the system and getting up and running? Like what's the minimum viable install of Dexter that you've seen? I'm just curious as to like how a team actually, gets on board and what that looks like.
Yeah, so, and it's an ever-present battle that we continue to work on, but we really strive to really embrace what we like to call the progressive disclosure of complexity, where simple things are simple, but complex things are possible, and the system kind of grows with you. The other term I heard of this is just-in-time complexity, where like the user is learning the system and then they have some problem that they've run into, and then all of a sudden you kind of like present them the next thing that solves that problem, rather than like overwhelming them. Now, I appreciate the compliment, Pete, about the system, but I still think we don't hit the mark we need to hit with in terms of progressive disclosure complexity, and we are actively working on that, which there's a ton of great work going on in the team, which I'm really excited about. But yeah, getting started is quite simple. If you want to just going from zero to viewing a pipeline in our UI is on the order of like a 2-minute process. You can write about 6 lines of Python, pip installs 2 tools, type Dagit, which is our graphical tool, and you're off to the races with this kind of very lightweight graphical environment, so you can get going. And then you typically the onboarding process is you're playing around with running the pipelines in an ad hoc way on your computer, writing some test cases around that. Then you think about productionizing it, and there's kind of we're an infrastructure neutral technology. So we have for example, a prefab Kubernetes deployment, but we don't require Kubernetes. You can deploy it to your own infrastructure. So for some of our users, deploying it to their infrastructure takes quite a bit of work to figure that out, and which is another thing we're working on. But yeah, we're big believers in just making it so you can kind of learn one additional thing at a time and kind of build up comfort with it and immediately get that feedback so you understand what's going on. Might have lost. Oh, okay. I think I lost you.
There we go.
About 20
lost
seconds.
You for a second.
Yeah.
Yeah. So you were talking about the implementation or the deployment, some of the deployment options around Kubernetes, et cetera, when I lost you.
Right. Yeah. What I'm saying is that, it's primarily a software abstraction. And we don't believe in, say, vertically integrating with something like Kubernetes, because not everyone uses Kubernetes, but it should be easy to use it on Kubernetes. So, once you want to deploy this to prod, if you're using kind of a well-known standard like Kubernetes, we have a Helm chart for it that's very configurable, and you can deploy it to your own infrastructure. But you can also deploy it to your own custom infrastructure if you don't use something like Kubernetes. We support ECS, for example. So we strive to be environment neutral as much as possible, and so that no matter what infrastructure people are using, people can still get value out of the tools and the API.
So you wouldn't say that there's any sort of minimum team size sort of required really to get up and running quickly and make use of Dexter?
No, it's a technology with a wide dynamic range. To me, like the idea that there's a minimum team size for structuring your computation into graphs is like saying like there's a minimum team size for using classes in a programming language. It's just like, it's such a fundamental way of structuring compute that it makes sense all the way from so-called single player mode all the way to massive multi-tenant scale. So like even and by the nature of the system and the fact that we so focused on local dev and testability, we kind of got all this single player stuff for free almost, because just by nature, if you're enabling a test and dev lifecycle in the context of a more like so-called production grade system, you kind of also capture just a one person being able to do interesting work on their own. Again, we view it primarily as a software abstraction. And one of the cool things about software abstractions is that they have like effectively infinitely dynamic range. Like one person can use it. It allows them to think about things more clearly, all the way to teams using it to structure the relationships between teams and whatnot. It's I think you should start using these from square one where you're developing data products.
Yeah. Well, I love how you think about leverage. It's really obvious in hearing you talk and how the system has been designed that it's of prime importance to you, because that's the whole game that you're in. And so it's nice to hear that so clearly. What are some of the more advanced features or power user features of Dexter that you're excited about? I don't know if there's anything new to preview for the community. Just sort of features that you think are maybe underused in general and should get more attention.
Yeah, I mean, I think the one that comes to mind is, I am super excited about the fully integrated asset catalog in a number of dimensions. I talked about being able to view longitudinal information about an asset, meaning like how long it took to compute over time and how many rows are in it and things like that. And then also the integrated asset lineage, I think, is just incredibly powerful because, the other thing I think is really exciting about the way we structure asset lineage is that we capture this immutable record of all the mutations, or what we call materializations of an asset over time. And that will allow us to do really interesting visualizations and searching, because asset lineage is a very challenging problem, often because of this time aspect, where it's like, okay, yes, this asset now depends on this upstream thing, but in the past it did not. And I want to be able to inspect that and be able to model that. Super important. And being, so that's natural. We'll be doubling down on more things related to assets as well. Like, for example, the term data mesh is very much in the air. And there's a lot of stuff incorporated into that term. And, it's like one of these buzzy terms that it means different things to different people. But there's this incredibly important idea within the data mesh, which I think is the most powerful one, which is that assets, meaning like data sets, machine learning model, the produced assets of a team should be the interface with other teams. So instead of having, if you depend on a team in like Airflow or traditional workflow orchestrator, you either have to put everything into one like mega DAG, which many teams do. And that's very difficult to scale and has a number of problems. Or you have separate DAGs and you're back in a world where the dependencies are not encoded. And so you're kind of like, why are we even using this thing? And, with an integrated asset catalog, we can make assets in the system the interface between teams and potentially be able to visualize that. And I think it's an incredibly exciting direction. And that means that teams don't no longer have to integrate their pipelines. They just agree on that. Oh, okay, our unit of interchange is this table here. And when you update this table, we can decide whether or not we want to instigate a computation again. And this sort of like structured, but more loosely coupled dependency, I think is a really compelling way to structure a data platform, and is the opportunity for the first time ever to really capture the structure of a multi-team data platform in a manageable way in one tool. So I'm super excited about that direction.
Yeah, that's really neat. So that's, you're talking about integration across teams, and when would, I guess, most teams presumably be using Dexter, or there'd be other sort of integration supported?
So, I mean, you can, we have first class sensors, which essentially means like event-based schedules. So you could potentially, you can eventually just events on like every time this S3 file gets updated, then run this thing. But if both sides of the equation are using Dagster, and we know that this thing, we know in a very verifiable way that this thing creates an entry in our asset catalog, and we know that this other one is listening for updates to that entry in the asset catalog, we can do much more for the user in terms of visualizing and structuring those relationships, rather than just like kind of sensors that we don't know what they do. So, the system is flexible and incrementally adaptable, so you can launch computations based on any external event in the universe. But we think this integrated asset catalog combined with the event-based computations is a really exciting direction to go. For formally capturing those relationships, because then like those two teams, they don't have to deploy on a synchronous schedule. They could even use different versions of Python. They can use their own dependencies. They don't even have to know the names of each other's pipelines. They just agree on a single asset key as their unit of interchange. And then we can also surface that information in very different ways throughout the system. So it's really exciting.
Yeah, that's very neat. Well, I want to zoom out just for a minute and sort of get your thoughts on the broader ecosystem, because I know that you are really convicted about the orchestrator being this amazing point of leverage across data systems, teams, tooling, et cetera. You've called the orchestrator, I think in the past, the town square, if I'm not mistaken.
I have used that line, yes.
So I'm curious, like, what's your philosophy on integrating with the other tools in the ecosystem? Like, how do you think about that? I'm sure that's front of mind for you, sort of, because orchestrator is at the middle, you have a pretty powerful role to play in how the rest of the town sort of aggregates around the square. Like, what's your philosophy there?
Yeah, I mean, I think the orchestrator needs to, be able to, like, in terms of where business logic is encoded, for example, whether it's in Spark or a SQL query or a Python, a piece of Python compute, that the orchestrator needs to integrate with any tool and any runtime in that way. So, the town square analogy or like the factory analogy is good, because you can imagine the different types of people, but they bring their own tools to that central location, and you can't exclude anyone because they're using a different tool. I think the other thing is that, all the other kind of many of the other tools that are not just like where you encode your business logic. So like, for example, say a data quality tool. The data quality tool has to play with the orchestrator to some degree somewhere, because who decides when the data quality test gets run? right?
Mm-hmm.
That
Mm-hmm.
is the orchestrator. So it makes
Mm-hmm.
sense for the orchestrator to be aware of that concept to some degree, but then to be able to invoke external tools that implement that concept. And so that's really the way we think about it. We want to be somewhat opinionated about process and the way that you structure pipelines, but as neutral as possible into the actual implementation of different tools that you use in the process of building that pipeline. Yeah.
Mm-hmm. Yep, got it. And another sort of high level question, Nick, because you've spent so much time building developer tooling, and I think the community appreciates your thoughts. Where do you get inspiration, as you think about system design or abstractions, even language design? Like where does that inspiration come from you? I'm curious.
Oh God, it's actually it's difficult to answer because I'm so submerged and immersed in the world, and I'm like always listening to podcasts and YouTube videos and reading stuff that that's difficult to isolate kind of one spot because it's kind of this continuous process, which I guess is kind of a cop-out answer. But like I really appreciate, like, for example, for my time at developer division, I really look up to, for example, like Anders Heilsberg, who's the designer of C# and now the designer of TypeScript, because I think he does an amazing job of having this vision end state in his head about where he wants these systems to be at the end of the day, but comes up with a an incremental way to get there, and then two, webs of abstractions that stack onto each other such that an individual one is independently useful, but the whole is greater than the sum of their parts. And so, I get inspired from a lot of these systems that embrace these composability principles that really respect both the problem that's being solved and respect the fact that developers, given kind of the proper framework, are actually quite clever and are able to kind of build the complexity and like give them the space to like innovate on top of your stuff. Like, to me, things are going right when people come out of the woodwork and are using the tools that you're building in kind of novel ways that you wouldn't have thought of. So I really look for systems that nail a use case, but also have kind of this ability for people to innovate on top of the platform.
Yeah, for sure. That's got to be very rewarding to see. Well, Nick, it's been great chatting. I'm really hoping and expecting that folks will want to check out Dexter. Where can they find out more information? I think you have a vibrant Slack community. Give us a couple addresses and tell us where people can find more about the tool.
Sure. So we're a GitHub project. So you can Google Dexter GitHub and look at our code and git clone it. We have Dexter.io, which contains our docs, links to all the things I mentioned, as well as a link to our Slack community, which is quite active. The team is always on there and very responsive. They are very dutiful and hardworking in that response. And even I get in there at some point when I have some time. I love talking to users and seeing what they're doing. So those are the primary resources.
Okay, great. Awesome. And just as a final question before I let you go, what surprised you most about your work in the data ecosystem so far?
Whoa, what has surprised me the most? That is a great question. And I guess as time goes on, what surprises me is just how deep the rabbit hole goes, so to speak, in terms of the number of problems that have to be solved. And it's self-evident in the number of tools and companies that are popping up. Like there's just clearly, all of a sudden you you wake up one day and you hear about not just a new company, but an entire new category that someone's trying to develop. It's like, oh, you wake up and now there's a metrics store startup, and oh, now there's reverse ETL. Okay, well, I guess that's a thing now. So, and it's not like they're making up terms on their own. These are fundamentally novel new things. So, just like the pace of expansion and the amount of opportunities, but that also causes confusion and complexity too, which is a whole nother question. But yeah, it's just like continually surprised me the number of problems that come up in the data ecosystem, and then the ingenuity of various folks in the community to fill those gaps. And the pace is just extraordinary.
Well, it is fertile ground for folks like you who want to solve that complexity. And there are many, many companies in the data council ecosystem who are continuing to pop up, and we're excited to continue to support them and to support you. So Nick, this has been really fun, and I can't wait to see you in person. It's been too long.
It has.
Well, thanks for joining us.
Thanks for having me.
And thank you to everyone who attended today. Thanks for joining the chat between Nick and myself. As Nick mentioned, there's all kinds of new stuff popping up in the data ecosystem. And in 2 weeks, we will have none other than Tejas Manohar from High Touch here to talk about reverse ETL. So make sure to join us for our next episode. Stay safe and be well, everybody. Look forward to seeing you soon.